This question should be manageable to most of us. And what we're going to do is to do 2 expansion first. Let's start with this. We have a 1 over 2 plus ax to the power of 5. And to do a binomial expansion for this, making use of the formula that we have in our formula sheet, we are going to re-express this as 2 plus ax to the power of minus 5. So the power here is a non-positive integer, so we are expecting an infinite polynomial when it is being expanded. So making use of the formula in our formula sheet, we need this to be 1. We are going to factorize out 2, so 2 to the power of minus 5. This is 1 plus a over 2x to the power of minus 5. 2 to the power of minus 5, this is 1 over 32. And expanding this is going to be 1 plus minus 5 a over 2x, then plus minus 5 minus 1, minus 6. This divided by 2 factorial, then a over 2x squared. Then finally, the third term, this minus 6, then minus 7 divided by 3 factorial, then a over 2x to the power of 3, and so on. Our aim is actually just to get the coefficient of x to the power of 3. So it is actually not necessary, and I believe for some of you, you don't actually have to do the entire expansion to extract out the coefficient of x to the power of 3. So go ahead if you can just take this out. I mean, just code this directly without doing the full expansion. So anyway, I've already done the entire expansion. So let me just write it down for you guys. This is going to be 1 minus 5a over 2x, then plus 15a squared over 4x squared. Then this is minus 35a cubed over 8, x to the power of 3, and so on. It is an infinite polynomial. Next, let's expand this, which is square root of 4 minus ax. And I'm going to rewrite this as 4 minus ax to the power of half. To make the first term here 1, we will factorize out 4. So 4 to the power of half. And we will have a 1 minus a over 4x to the power of half. And this time round, we are going to be extracting out the coefficient of x to the power of 2. So let's expand until we get a x to the power of 2. 4 to the power of half is 2. And this is going to be 1 plus half. And minus a over 4x plus half. Half minus 1 is minus half. So this divided by 2 factorial minus a over 4x squared, and so on. It is an infinite polynomial again. So this is going to be 2 here. It is going to be 1 minus a over 8x, then minus a squared over 1 to 8 x squared, and so on. So we are going to be comparing the coefficient of x to the power of 3 and x to the power of 2 here. Extracting out the coefficient for x to the power of 3 from here, we are going to be having a 1 over 32. Let's not forget about this. Then multiply by minus 35a cubed over 8. Okay, and this is equal to 5 times of the coefficient of x squared of this particular expansion. So it will be 5 times of, let's not forget the 2 times of minus a squared over 1 to 8. And since the question says that a is a non-zero constant, so we can divide by a squared throughout, which will leave us an a here. And if I bring all the coefficient over to the right hand side, we will get the exact value of a, and that is 4 over 7.